Hello, Algebra 2 students. I'm going to go over a really quick way to show you how to use the unit circle to evaluate inverse trig functions from 0 to 360 degrees. This is a slightly different approach than the delta math video, but if you have the unit circle already printed out, this is a really quick way of evaluating what the sine, cosine, and even tangent of those functions are. And we could even talk about the other functions like cosecant, secant, and cotangent. They're just the reciprocals. But this is just for sine, cosine, and tangent. We won't talk about how these values are created. That's a different piece you'll learn in pre-calculus, but this is just getting you guys used to the unit circle. So let's start off with this. And around the unit circle, it's split up, and we have divisions of 30, 45, 60, and 90. And you can go around the circle, see the different degrees. You also have the radians that are matched with it. The piece that I want to identify is, notice at each point you have an ordered pair. You have an x value and you have a y value. Well, another way to think of that is the x value is actually the cosine of that angle. And then the y value is actually the sine of that radian or degree. And I'll show you what that means as we go throughout. The couple things that you just need to know is when we talk about the sine function, the sine value is the y value of your ordered pair, and the cosine is the x value. So what about tangent? Well, tangent is actually the ratio of sine over cosine. And if we take from what's above, the ratio of tangent is the y value over the x value, and that's the way that we're going to identify tangent here. So let's take a look and do a couple problems using the unit circle. If I want to find the cosine of theta is equal to 3 square roots of 2, another way to ask this is, what angle measure gives me the ratio of 3 square roots of 3 over 2? Well, what we're really looking for is, what is cosine? Cosine is the x value. So I'm going to search around the unit circle, and I'm going to look for, when is the x value of the point square root 3 over 2? And if I look at it, the x value here is square root 3 over 2, which is 30 degrees or pi over 6. So my answer, one of the answers, is is 30 degrees. But that's not the only answer. Cosine is also positive. Notice, if x is positive, that means I went to the right. If I go to the left and up 30 degrees, then I would be at negative square root 3 over 2, and we don't want that. We want the positive version. So if I go to the right, the only other spot where x is a positive square root 3 over 2 is 30 degrees below the x-axis at 330 degrees. And you can see right here, look at the x value. The x value, which is cosine of 330 degrees, is positive square root 3 over 2. So the other answer we're looking for is right there. All right, we're going to try a couple more. If I scoot this up, on the bottom here, we've got cosine of negative pi over 2 divided by 2, and we're looking for, when is cosine negative? So let's think about that. Cosine is the x value. If the x value is negative, it has to be when we go to the left. So if I go to the left and I figure out, when is the x value negative square root 3 over 2? Negative square root 2 over 2. That is going up 45 degrees. Here's the x value, which is cosine, and that's going to give me the answer, theta is equal to 135 degrees. Or, where else is cosine negative? Well, that's the x value, so I'd go to the left and down, and here it is at negative square root 2 over 2, and that is at 225 degrees. Now notice, we could also ask you what it is in radians, and you have that match right here. So what about sine? When is sine equal to the sine of theta equal to negative square root 3 over 2. So we're asking what angle measure gives us the ratio of negative 3 over square root 2? Well, sine is now the y values. And we just need to look. Now let's think about that. Y values, if y is negative, it's going to be below the x-axis, so my two answers should be below the x-axis for the y values. And let's figure out what y value has negative square root 3 over 2. Here's one right here at 300 degrees, so theta would be 300 degrees or 5 pi over 3. The next one, the y value is negative square root 3 over 2, which is 240 degrees or 4 pi over 3. So what about tangent? I didn't really think this one out too clearly, so I'm going to have to shift quite a bit. Apologize here. Tangent of theta is undefined. Well, wait a minute. Undefined means something very special. Undefined for us is referring to you can't divide by 0. If something's divided by 0, it's undefined. So I have to look and see when the bottom number of the ratio is 0, and the top number could be really whatever, but in this case it will be 1. And why? Remember what tangent is. Tangent is sine over cosine. So we're looking for when is the sine value, which is y, and the cosine value, which is x. When is sine equal to 1, and when is cosine equal to 0? So when is the y value equal to 1? If I look at the point on the origin at 0, 0, 0 degrees, 0 radians, the x value is 1 and the y is 0, but we don't want that. We want right up here. When is the x value 0 and the y value 1? Well, at 90 degrees, we get the ratio of 1 over 0, which is undefined. And then there should be one other point. So if I come back to this, I still want my x to be 0 and my y could be positive or negative. But if I come over here and I look at the bottom, my x is 0, my y is negative 1. So I should have probably put a plus and minus right here. But the other possible answer is at 270 degrees. We get an undefined ratio. So what about when tangent is equal to 1? That's kind of an interesting one, because a ratio of 1 is the same as 1 over 1. Let me scoot up here. I want to figure out when is the ratio of sine over cosine equal to 1. Now this 1 is a little misleading. I don't have any points that are 1, 1 on this entire unit circle, because if that meant over 1, up 1, that would put me outside of the circle. That would have a different radius than all the other points. So we have to stay on the circle. But what that means is, let's think about what your ratio is actually telling you. If the sine over the cosine is 1, any number divided by itself is equal to 1. So what this is actually telling us is when is the sine value the same as the cosine value? All right, let's take a look here. If I go over, notice at 45 degrees, sine and cosine are the exact same numbers. If I divide those out, sine over cosine ends up giving me 1, and it's a positive 1. If I moved over to the right, though, I would have a negative and a positive. So I'd have a positive divided by a negative. That wouldn't give me positive 1, that would give me negative 1. So I need to look for when is sine and cosine the exact same values and both the same signs. And notice right here, at 225 degrees, I get negative square root 2 over 2 divided by negative square root 2 over 2. Actually, I should have said the y is on top over the x, because that's what sine over cosine is. So we have two possible answers here. At 45 degrees, sine and cosine are the same values and the same signs. At 225 degrees, sine and cosine are the exact same values but negative. Negative divided by negative is still a positive. All right, last one here, and this one's a little bit tricky. This is kind of the tricky one. Square root 3 over 3 is actually something we need to rewrite, and we're going to unreduce a radical here by using a little property from pre-calculus or from geometry. This is a reduced version of a ratio that we had before. So if I unreduce it, I'm going to actually turn it into a ratio of square root of 3 times the square root of 3 is 3, and on the bottom I get square root 3 over 3. Well, those are going to reduce out, and I'm left with 1 over square root 3. So another way to think of this is the tangent of theta is equal to 1 over the square root of 3. But we don't have sine and cosine that look exactly like this. What actually happened was this ratio was reduced as well. Another way to think of this is we had a 1/2 and a square root 3 over 2 where we have sine and cosine. Now, how did I get that, and why did I know it was over 2? There's some patterns here that are in the unit circle that just comes out, but I want to show you why that is. If I have 1/2 divided by square root 3 over 2, remember dividing by a fraction is the same as timesing by the reciprocals. If I times by the bottom of square root 3 over 2, those 2's reduce out, and that is where the 1 over square root of 3 came from. So that's why I knew kind of how to turn this into that ratio of 1 over square root of 3. Well, what does that mean? When is sine equal to 1/2 and cosine equal to square root 3 over 2? Now notice they're both positive. So if sine is the y value, that means I'm going to be going up. And if cosine is the x, I'm going to be going over. Both are going to be positive. It'll be in this first quadrant. So when is sine equal to 1/2? Sine is equal to 1/2 at 30 degrees. And when is cosine equal to square root 3 over 2? If I was to do that ratio, that would tell me that theta would be 30 degrees. But don't forget, positive, negative could also be when both of the items are positive or negative. So we're looking for the same point, but just negative sign. So when is cosine equal to negative square root 3? That's the x value, negative square root 3 over 2. When is the sine value equal to negative 1/2 over 2? I get 210 degrees. That one might be a little bit more tricky. The Delta Math video might explain that one a little bit better, but all the other ones I think are kind of a quick way to look at some videos. Good luck. Let me know if you have any questions.